Unit 3, pages 95 to 98. Rules of differentiation. Finding derivatives of exponential and logarithmic functions with bases other than e. So in the previous video, we found the derivatives of natural, exponential, and natural logarithmic functions. Today we're going to look at exponential and logarithmic functions that have a different base rather than e. So the differentiation rule for exponential functions is f of x equals a g to the x. So if this is true, then f prime of x equal to a to the g of x times g prime of x times ln of a. So if the above function is how we get the derivative for exponential functions, then why did we not do this with logarithmic functions whose bases were e? So what I want you to do is find the derivative of these boxes below. So for the first derivative, we're looking to apply f prime. We're looking to find f prime applying the rule from the previous lesson. So the previous lesson told us that to find f prime of x, we take the original function, so e cosine 2x, and we multiply it by the derivative of the exponent function. So cosine 2x, this is a chain rule problem, so the 2x is its own baby. So we have the derivative of cosine, which is negative sine, the derivative of 2x, which is 2, so we'll have negative 2 sine x. We can rewrite that f prime of x equals, this is negative 2 sine 2x, equals negative 2 e to the cosine 2x times sine 2x. Right? And if we apply the rule above, then we know that the derivative of f of x equal to the original function times the derivative of that inner function, cosine 2x, which we already found to be negative 2 sine 2x. All of that times the ln of the base, which is e in this case. Ln and e cancel each other out. So this is 1. So then f prime of x equals negative 2 e cosine 2x sine 2x times 1. So it's the same as the left side. Okay, so now we want to find the derivative of each exponential function below. I'm only going to do 2 of these problems, and you're going to do the other 2. So the 2 I'm doing are f of x and g of x. So if I want to find the derivative of f of x, so we know 4 is our base, and x squared is our exponential function, or our exponent function. The derivative of that is 2x. So we'll have the original function, 4x squared, times the derivative of the exponent function, which is 2x, times ln of the base, which was 4. So f prime of x equals 2x times 4 to the x squared ln of 4. In g of x, we have product of two functions. We have x squared and we have 2 to the 2x. So this is function number 1, and this is function number 2. So if we remember product rule, we know that we need function number 1, which is x squared, the derivative of function number 1, which is 2x, function number 2, which is 2 to the 2x, and the derivative of function number 2, which would be 2 to the 2x times 2 times ln of 2. So product rule says we'll have the derivative of the first function, which is 2x, times the second function, which is 2 to the 2x, plus the first function, which is x squared, times the derivative of the second function, which is 2 to the 2x times 2 times ln of 2. So when we simplify, get g prime of x is equal to 2x 2 to the 2x plus 2x squared 2 to the 2x ln 2. Right, so what I want you to do is work on on h of x and p of x on your own. And we move on to the next page. All right, on this page, I want you to try f of theta. You will need to use product rule. There's a little bit of chain rule going on in there, so be prepared for that. So for f of x and h of x, I'm only going to do f of x in this case. So for f of x, we have a quotient function, so we're going to need to use the quotient rule. So high and low. So our high function is 3 to the 5x. So the derivative of that would be 3 to the 5x times 5 times ln of 3. Our whole function is x. So our derivative of our whole function is 1. And when we use the quotient rule to find this, we know we'll need ODI, so x times 5, 3 to the 5x ln 3 minus Heidi Ho, which is 3 to the 5x times 1 all over whole squared, so x squared. You can factor out a 3 to the 5x from both terms in the numerator, so you'll get that the derivative of x equals 3 5x 5x ln 3 minus all over x squared. Okay. I want you to try h of x on your own, and we're going to do the last problem on this page. All right. So for what values of x would the graph p of x equals 2 to the negative 3x have a normal line whose slope is 2. Show your work and explain your reasoning. So we're going to at least need to find p prime of x. Definitely, if we're looking at normal line, we know that we can find the slope of the tangent. So if this is the slope of the normal, then the slope of the tangent must be its negative reciprocal, which is negative 1/2. Okay, so in order to find p prime of x, we know that we're going to need to find the derivative of negative 3x, which is just negative 3. So p prime of x is the original function, which is 2 to the negative 3x, times the derivative of that exponent function, which is negative 3, times ln of the base, which is 2. So we're looking for what value of x the graph would need to be to have a normal line whose slope is 2. So if we know the normal line slope is 2, we know the slope of the tangent line is negative 1/2. So slope of the tangent line is p prime of x. So we have negative 1/2 equal to 2. Let's just rewrite this. So it's equal to negative 3, 2 to the negative 3x ln of 2. And all you have to do now at this point is plug it into a calculator, and you'll get that x is approximately 0.6854. So to explain your reasoning, you know that when the slope of the normal line is 2, slope of the tangent line is negative 1/2. Therefore, we are looking for when p prime of x equals negative 1, which occurs at x approximately 0.685. All right, moving on to page 97. Now we're looking at the differentiation rule for logarithmic functions. So if f of x equals log base a of g of x, then f prime of x equal to g prime of x over g of x ln. Right. And for this, a must be greater than 0 and a cannot equal 1. Okay, so let's see same relationship that we saw between the derivatives of natural exponential functions and those that have bases of e, and the derivatives of natural logarithmic functions and the logarithmic functions that have bases of e. So in the previous lesson, we found the derivative of the natural log function pretty simply as taking the derivative of the inner function and dividing it by the inner function. So the derivative of this inner function using chain rule we know is going to be 3 cosine 3x. So that's d dx. So the derivative of this entire function is 3 cosine 3x all over sine 3x, which is just equal to 3 cotangent 3x. Okay, and so now using the rule above, we still need to know the derivative of sine 3x, which we know is going to be 3 cosine 3x. So the derivative of f of x using the rule above is equal to 3 cosine 3x all over sine 3x ln base e. And ln and e we know is going to be 1. So f prime of x equal to 3 cosine 3x all over sine 3x, which is just 3 cotangent 3x. All right, I'm going to use this rule on 2 of the 4 problems below. So the first problem I'm going to use it on is f of x. So log base 2 of f of x. So my base is 2. F of x is my inner function that I want to take the derivative of, which will be 4. So I'll have that f prime of x equal to 4 over 4x ln of 2. The other function I'm going to do is h of x down at the bottom. So h of x is equal to log base 5 of cosine 3x. So we need to find the derivative of cosine 3x, which would be negative 3 sine 3x using chain rule. So h prime of x equal to negative 3 sine 3x over cosine 3x ln 5. Okay. I'd like you to work on g of x and p of x on your own. And we're going to move on to the back. Page 98. So for page 98, I'm only going to do 2 problems on this page. I will do k of x, and then I will do the problem down at the bottom of the page. So for k of x, we're going to rewrite k of x so that we can see better what's happening. So we have log base 7 of x squared minus 1 to the 1/2. All right, so then in order to use my logarithmic rule, I would need to know the derivative of this inner function, which is the x squared minus 1 to the 1/2. So to do that, I will need to use chain rule. So I'll have 1/2 x squared minus 1 to the negative 1/2 times 2x. So the derivative equals that for now. When I simplify this, I get x over square root of x squared minus 1, which is just equal to square root of x squared minus 1, x times square root of x squared minus 1 all over x squared minus 1. So k of x, or k prime of x, is equal to the derivative of the inner function, which we found on the side here. So x squared minus 1 all over x squared minus 1. And that over square root of x squared minus 1 times the ln of 7. And when we do this out, we get x squared minus 1 over x squared minus 1 times 1 over square root of x squared minus 1 ln of 7. The x squared is minus 1, so we'll cancel out, and we'll get 1, so we'll get x over x squared minus 1 ln of 7. All right, for p of x, we're going to need to use the chain rule on sine x squared. So bring that over to the side, and we'll use the chain rule. So d dx will be equal to cosine 2x, no, cosine x squared times 2x. It's just 2x cosine x squared. So now to find the derivative of p of x, it'll be equal to the derivative of our inner function, which is 2x cosine x squared, all over the inner function, which is sine x squared, times ln of the base, which is 2. All right, the last problem that we're going to do is figure out for what values of x will the graph h of x have a tangent line whose slope is 5 over 2. So if we're looking for a tangent line, this means that this is the SOT, which is 5 over 2, and that is also going to be h prime of x. Okay, so to find the derivative of h, we're going to need to use quotient rule on the inner function. So we'll do that over here on the side. So my high function is x. The derivative of my high function is 1. My whole function is 2x plus 1. The derivative of my whole function is 2. So d dx equal to ODI, so 2x plus 1 times 1 minus high d ho, so x times 2 all over whole squared, so 2x plus 1 squared, which is equal to 2x plus 1 minus 2x all over 2x squared, which is just 1 over 2x plus 1 squared. Okay, so now the derivative of h of x is equal to the derivative of that inner function, which we know is 1 over 2x plus 1 squared, all over the inner function, which is x over 2x plus 1, times the ln of the base, which is 2. So to make this easier to see and simplify, up into 1 over 2x plus 1 squared times 2x plus 1 over 2x plus 1 cancel out. So we get 1 over 2x plus 1 x ln squared. And we'll set that equal to 5 over 2. Plug it into a calculator and you'll get approximately 0.3425 and negative 0.8425. And when it comes to explanation, if the slope of the tangent line is 5 over 2, and we are looking for when h prime of x equals 5 over 2, which occurs at x approximately equaling negative 0.8425 and x approximately equaling 0.342. That is the end of the video.